So I know you just got out of school, but welcome back to school. You're gonna learn something today, and we're taking notes. And by we, I mean Skitten's taking notes.
Yeah, me. So when I was in college, when I was in college, I used to take extensive notes. You know how your professor may or may not have, all of my professors did this until like my junior year.
What? Like
when they put up their PowerPoints.
Yeah.
Okay. And they would have like a header and then the bullet points and then the points under the bullet points.
The PowerPoint.
On the PowerPoint, yeah.
Yeah. Use bullets, yeah. That's how bullets work.
So apparently all professors don't do that.
What do you mean? That's the normal, that's the number one setting for PowerPoint.
Some professors just have pictures on their PowerPoint. And then
Who does that?
And then they talk about the pictures and I'm like, I don't know how I'm supposed to take notes. My point is, I've always been very good at taking notes. I've always taken extensive notes. I still have notebooks full of copious amounts of notes.
Do you still have your notebooks?
Yeah, you didn't make me throw them away yet.
I haven't found them. I am on the other side. I took pretty good notes for me, you know? I took pretty good notes, but I didn't see the point if when you put up a PowerPoint and all it has is the stuff in it I just read for class yesterday, and I just write the page number down and go, this is just the page put on PowerPoint.
Yeah,
That's why I save so much time on notes.
Point is,
there we go.
I'm ready for class, okay? I have my pen, I have my notebook. I'm gonna try to take better notes this time than I did last time. She talks real fast.
You took great notes last time.
It was not up to my standard.
If you're ready, you got your notes or you got your learning brain on, let's get started.
Last time people pointed out that I was looking down a lot. It's because I'm taking notes.
What did you think she was doing down there? Staring at her knees?
They were like, why does Skitten keep looking? I'm writing notes. I could write like this, I guess, and be really obnoxious about it, but I was trying not to do that.
Like peek out the way of the book. Like, I still gotta see the screen.
All right.
Sometimes you like to roll your sleeves up, other times you don't, you know? The duality of woman. All right.
Why?
After a devastating mass...
It's so black.
Oh, man. It's like super dark.
It's like... it's like really black.
No, it's absorbing light.
Which is like... I don't know if that's like politically correct for us to acknowledge how black the shirt is.
Oh, wait a minute. It's also really clean.
It is a clean
That's not a
black
speck of
shirt.
white on that fucking black shirt.
Yeah.
Yeah.
You got a fucking Vanta black shirt and just casually wore it and didn't expect us to say anything. Okay, all right.
Devastating mass extinction wiped out 85% of species alive on the planet. Life was starting to recover in ways the world had never seen before. It was the start of the Silurian period, which lasted from 443 to 419 million years ago.
Okay.
During this time, vertebrates started to get major upgrades, new traits that are still around and crucial for survival today. And invertebrates started to migrate to seemingly inhospitable habitats. Plants and fungi had some cool new shit going on. And of course, during this time, there were specimens that were weird as fuck. I'm gonna put this all into a little rundown and give you a glimpse of what life was like during this global metamorphosis.
I'm ready.
My name is Lindsay Nikole.
Yeah, we know.
And this is the history of life on Earth.
This is the history of life on Earth.
All right, let's get the global conditions out of the way.
She talks in bullet points.
Yeah.
Yeah.
She's doing it on purpose so we can follow along. Yeah.
She's putting the emphasis on the right syllable.
I love it.
Supercontinent Gondwana, as you would probably guess, is still hovering over the southern pole. There's a chain of some smaller continents kind of hovering over the equator. If you remember during the Ordovician mass extinction, the world was smacked with a global cooling. Glaciers sucked up some sea level, which led shallow water habitats to not exist anymore. But then the Earth looped back around with a backhanded global warming. So going into the Silurian, those glaciers melted, which led to much higher sea levels, and land masses got covered in shallow seas. This made for a nice and cozy expanse for marine inhabitants, and allowed many groups to recover. If you remember during the Cambrian and Ordovician, the fishes were pretty much tadpole-like and shit, jawless, sucking shit off the ocean floor, and that's all there was to it. So what were the fishies up to now? Well, this is the time they went absolutely berserk. Diversification off the charts. Jaws appeared for the first time. Different types of fins, ray fins, lobe fins, cartilaginous skeletons, jawed fish with armor. Characteristics that were the building blocks of lineages that would allow them to interact with the world in unbelievable ways, such as me, using my finger to point to my mouth to tell you about the evolution of jaws and lobed fins. Holy fuck. It's like evolutionception. Let's start off with what probably perked your ears up in that list, the development of jaws. This is a weird development because it seems like something that appeared out of nothing, even though obviously it didn't. Recently, for some reason, I've been getting more DMs than usual asking about the mechanisms, the process of evolution. You know, like I get that whales evolved from land animals, but What?
Huh?
And I just finished reading The Selfish Gene by Richard Dawkins, so I'm feeling real fresh. And I kind of want to over-explain the development of Jaws to use it as an example in this case to help like visualize it.
What nerds are out here
Please go ahead, because I was also waiting for a
sliding
chance.
into Lindsay Nikole's DMs?
How you doing, Lindsay? I was just wondering about the developmental processes of Jaws, because I get that we have them, I get how they work, but how do you go from to munch? You know what I mean? Can you give me some more details on that, bro?
I would just like to be clear that if I was sliding into Lindsay Nikole's DMs, it would not be to talk about Jaws.
It would be to invite her to Barcode Burger.
Yeah.
Super local spot, best
Absolutely.
burger in Vegas.
So good.
We're such good dinner people.
Or
You would
sushi.
love it. I mean, gorilla sushi is a thing. Talk about fish. What if you get a little fishy fish going?
I'm just
You know
saying.
what I'm saying? I'd be like, hey, Lindsay, you want to come to sushi with me and my wife? We would love to have you. I have to come to you as a woman. Your husband's in my DMs. You're like, oh, honey, I'm invited.
I would hope so. I sent him to your DMs, actually.
Read Selfish Gene if you haven't already. I was probably assigned that in biology class and just
course
didn't
you
read
were.
it. And so I just finished reading it for the first time. It's great for understanding this. It's
Yeah,
long,
but it's a
so get
lot.
the audiobook, listen to it like a podcast. But easy. Okay, so like I said, Jaws didn't
Jaws.
appear out of nowhere. The classic idea is that they evolved as a modified form of a trait that was already existing in jawless fishes. They're gill arches. Gill arches are structural loops made out of bone or cartilage that support the structure of gills in fish. They've been present in vertebrates since the Cambrian, so have essentially been a component of fish since the beginning of fish that we know of. Gill arches are great for increasing the surface area of the gills, which allows more oxygen to get into their body at a given time. Absorbing oxygen more efficiently is obviously beneficial to the survival of the little guy. So gill arches that are more and more efficient are going to develop over many generations, as variation in that trait in the population will give some an advantage over others. Little guys with slightly more efficient gill arches are likely to survive and pass on those genes at a slightly higher rate than others, and
Right.
so on. So these gill arches became more modified as time went on, and something strange happened. The pair of gill arches closest to the mouth pushed forward over time for efficiency until they were essentially around the mouth opening, creating some sort of basic form of a mouth structure. Now, these gill arches, which had a primary purpose of getting oxygen into the body more efficiently, served a secondary purpose, providing a very basic and very slight form of grabbing power, giving them a slight advantage over the ones still stuck sucking up shit from the ocean floor, the mouth
Right.
structure. This provided a blueprint for those modified gill arches to evolve over time, for more efficient grabbing power as generations went by. This developed into a stronger and stronger structure until it could eventually be labeled as a proper jaw
That's
by our
freaking
definition.
cool.
And of course, remember these changes happened at an unnoticeably slow rate.
Right.
Like, you can't expect to watch grass grow if you sit there for a bit, but if you come back a few days later, you gotta mow it. There have been some changes. But like in this case, come back after millions of years, thousands of generations, then you can mow it then. I mentioned
Yeah.
this is the classic idea because as technology has advanced, there are new hypotheses developing based on like gene expression and shit. But I'm gonna stick to the classic idea because it's still valid. As of right now, it is still accepted and it is simple and a good example. And hopefully it was a helpful example. And if not, I will eventually try again at a later date.
Okay.
Okay.
Thank you.
So, just to run down people who did not do this in class already.
There was a fish explosion.
Oh,
Guts everywhere.
it was we're at 443 to 419.
Yes.
Okay.
With jaws and lobed fins. They looked
Ah,
like robed fins,
lo-
and I was very
Road
confused.
like Caesar. Road
Yeah.
fins.
All right.
Okay.
Jaws evolved as a modified form of gill arches.
Yeah, and so we had that a lot of videos about the insect videos where people talk about how well, actually just one guy. Welcome back to the video. But he said it's very interesting how there's so much evolution and efficiency for a lot of other animals, and then for insects, you constantly hear about they've been doing the same thing for millions of years.
Yeah.
And that is exactly how it works. If it doesn't improve your life, you leave it out.
Yeah.
You know, and some inefficiencies kind of stick around. Doesn't mean you're going to be the most optimal form, but if you're living, you're winning, son.
Stink bugs.
Okay, then.
They explode themselves.
Right. But after they lay eggs and procreate. So evolution goes, there's nothing wrong with this dude. We're still out here.
Actually, you might remember that I talked about it before with the brittle stars that can see without eyes in the All-Stars video. They're a chromatophore network likely assisted in camouflage and predator avoidance, and just so happened to make an impact on their existing photoreceptor network that allowed them to sense light versus no light. When those two networks kind of pushed into each other, it somehow created some sort of an image, allowing them to see without eyes. The technical term for this is an exaptation, trait that takes on a function different than its original function. Back to this particular exaptation, the development of the jaw. It obviously helped fish go bananas. New niches and strategies developed for this cool new weaponry. So, allow me to introduce you to these first jawed fish that appeared in the Silurian, the placoderms. The Silurian was like bread and butter. They developed armor for protection, pectoral fins for balance and stability, and primitive tail fins. And look at that. We still see fins today. And they diversified to shit. Actually, let's draw a little cladogram.
Please do.
So we can keep track of all this. The development of jaws led to placoderms, and placoderms diversified to shit. So jaws...
I was so ready. I started copying her.
And it just ended. So that says what? Bones on the bottom? And then what does it say on the top?
Cartilage acanthodians, aka spiny sharks.
Got it.
Led to placoderms. And placoderms are the ancestors to bony and cartilaginous fish. Yes, from the shark video. Chondrichthyes, the cartilaginous fish we know today as sharks, skates, and rays. These are the roots of that lineage, the acanthodians, also known as spiny sharks due to their shark-like appearance, even though they were not sharks. Just at the base of the lineage that would eventually lead to sharks. They first appeared here during the Silurian and existed for like 200 million years.
Damn!
They were found in oceans all around the world, so... very successful group. Spiny sharks only had teeth on their lower jaw, and some even seemed to have replaceable teeth at this time. They had big eyes and were likely active predators, feeding on crustaceans and other fish. Okay, so that was the beginning of the cartilaginous root. On the bony root, there were some notable species. Bony
here we go.
Bony skeletons, like Intelinathus primordial, whose name essentially means complete primitive jaw. The first fossils of them were discovered in China back in 2013. Matter of fact, take a shot every time I say China, because it's gonna come up a lot in the next like 2 to 4 minutes. They're seen as a transitional species between more primitive and modern fish due to their particular set of characteristics. Another one from China called Silurian rostrata. Kind of looks like a dolphin. Really exemplifies the fact that shit got weird almost immediately after Jaws evolved. The bony fish went in a couple directions as well. The ray fin, with fins made of cartilaginous rays. This is most fish alive today. Think goldfish, think blobfish, think my son the deep sea telescope fish, think beta fish, etc. There was also the lobe-finned rat, with fins made of a series of bones. Think coelacanths, think lungfish, think us. Yeah, these were the ancestors to tetrapods.
So I see some of you guys are out there taking notes and you're representing her notes, and you see these side diagrams, but you have a paper that goes up and down. So a small hint that you can do is you start the label at the top as A, and then you go down and you label downwards. You don't go out to the side, because you'll never have enough room. When that keeps going to the right, you're gonna run out of room.
Animals with 4 limbs. That would come a bit later, like tiktaalik, amphibians, dinosaurs, the platypus, etc. These bony fins eventually led to...
You didn't wear your axolotl shirt.
I should have worn my axolotl shirt.
Yes, next time.
Tiktaalik, amphibians, dinosaurs, the platypus, etc. These bony fins eventually led to the evolution of the limbs we know and love today. But we'll get to that in a couple episodes. But let's get back to the name. One of the earliest lobe-fin fish that we know of is called Cerolepis ramiri.
I am focused on my schoolwork.
What?
You are just a man trying to distract me from what's important.
You talking about the words or the touching? I used to do both in school, so I'm not sure which one's more distracting.
This is why my mom was like, stay away from boys when you're in college. Also, because I was 15 and it was
I was getting ready to say, is that why? Do you want to break that down more? Yeah, I didn't meet my wife in college when she started college. No. I met her at the end of that journey.
Ramira. Another one first found in China in 1998. They had some pretty gnarly teeth for their time. And the largest Silurian lobe-finned fish that we know of is called megamastix. Big mouth butt teeth. They're pretty much considered the first vertebrate apex predator that we know of, and could get to like 3 feet long, 3 times the length of any other fish alive
not so bad.
we know of. They were also found in, you guessed it, and kind of changed the way science viewed Silurian fishes, because before their discovery in 2014, fishes were thought to be pretty restricted in their size at this time. At this point, I'm sure you are downright exhausted hearing me talk about fish.
No.
I am absolutely exhausted talking about it as well.
Okay.
Let's move on to the spooky shit.
All
Erase. All right. The
Here we go.
strange specimens. Starting off with a group we are already familiar with, the sea scorpions.
Yeah.
They were somehow still kicking after the Ordovician mass extinction and hadn't even hit their prime yet. These apex predators continued to be apex predators pre and post extinction and even beyond the Silurian. Their most heinous form during this time was Pterogodus, one of the largest sea scorpions to ever exist.
That is badass.
That looks like something that frickin' HP Love Races would write about.
Do you know what that looks like?
Huh?
The giant crab from
In
Dark Souls
Souls
3.
Yes,
That's
it
what
does.
it looks like.
Yes,
and it
it
will
does.
eat you. Just so you know.
No, that crab will mess you up. There's still someone somewhere down there just waiting for it.
in a hole, just eating things.
As global warming happens, it's like, yes.
This is my time.
Yes.
That we know. They can get to about 6.
6
Holy hell! It was huge! It was huge!
Feet long, with fossils found on every continent except Asia and Antarctica, at least for now. Fossil evidence suggests they had a pretty advanced visual system, all the better to see with, as well as extremely strong punching and crushing chelicera.
Really?
Punch and crush with.
Anyway, I started blasting.
You know who else punches furniture? My wife.
Doors are not furniture.
Close enough. Skitten.
And I don't punch them
Yes,
out of
you
violence.
do.
I said out of violence.
Yes, an internal rage. She'll walk out a door, like, stop hitting it with combos. At least leave it to one punch. Stop with both.
They were, not surprisingly, a high-level active predator. A horrifying trailer for the forms that were to come in the millions and millions of years later that we will get to in the next period.
Huge
and what
crabs.
about the trilobites?
Trilobites!
Yeah, they somehow also survived the land plant apocalypse.
Hell yeah.
They did lose about half of their diversity, which was obviously not great for them, but they
need
did
'em.
recover pretty quickly and still managed to inhabit every corner of the earth, except for the poles. So yeah, trilobites were still around, still doing their little lock and roll pose.
Hell
Here's
yeah.
one that is definitely unlike anything we've talked about so far. Solacina Cthulhu, more recent discovery from the
Oh my god!
Yeah.
Yo, these things are getting nuts.
Hell yeah.
Solacina
Hell yeah.
Cthulhu. I want that on a t-shirt, please. Thank you.
Solacina.
You know, you asked me what I wanted for my birthday.
It's too
I
late.
want one of those.
It's too late.
I want like that
It's too late.
in a box, and I would like to carry it to work with me.
I've been asking this man
Yes?
since February.
February. That's about right.
February.
Yeah.
Hey, babe. You thought about what you want
Too
for
early.
your birthday?
Way too early.
So he said it was too early. He said I need time. It's too soon.
Yeah,
it's
it's too soon.
So I said, okay, that's fine. I wait
Yep.
till April. His
That's
birthday's at the beginning of June.
too
BT
soon.
dubs.
It's too soon.
Wait till April. I said, hey, babe,
No,
have you
too much time.
considered anything that you might
There is
want for your birthday?
literally 8 birthdays between April and my birthday. Actually, 10 birthdays. There's children now. Too many birthdays.
No, I haven't thought about it. There's too much going on.
Not ready.
I said, okay. It is May 24th.
And we just finished the last 4
It
birthdays.
is May 24th.
We finished 4 birthdays.
It is May 24th.
And now I'm ready.
As of the shooting of this video.
I'm ready.
His birthday is in less than a week.
I'm ready now.
Or
It's
a little
time.
over a week.
There's only one birthday.
And now, he wants to be like, oh, well, I want this, and this for my birthday. How am I supposed to get it here on time? Because just to be clear, my husband doesn't want something that I can just get him off of Amazon. No, he
right.
wants custom. He
Yeah.
wants unique.
Yep.
He wants hard to find.
Yeah,
He doesn't even know what he wants until he sees it.
quality. That's right. And I saw you, and I want you.
Don't touch me right now.
in 2019 and named after the Lovecraftian tentacled
Of course,
monster.
yeah.
It had 45 tentacle-like feet. They used to crawl along
Jesus.
the ocean floor. As you
I'm
probably
sorry.
guessed based on the
Jesus.
fact they were found so
I'm so
recently,
sorry.
like feet. They used to and named
Jesus.
after the Lovecraftian tentacled monster. It had 45 tentacle-like feet.
45!
They used to crawl
Okay.
along the ocean floor. As you have probably guessed based on the fact they were found so recently, we don't know much about them. Scientists figured out they were
2019.
some sort of early echinoderm related to sea stars, sea urchins, sea cucumbers, etc. All the weird animals I talked about in the All-Stars edition of What the Fuck Is This? But what particular echinoderm form were they most closely related to? Let's take some guesses. If you had to guess, do you think Solacina Cthulhu would be most closely related to sea stars,
Anemones.
brittle stars, sea urchins, or sea cucumbers? Take
I'm
a
going-
good second to think about
I'm
it.
going star.
Gas!
I'm
The
going
first
with
one.
the
I'm
brine
going
gas.
Yes,
Or brittle
goddamn you!
stars.
Why won't you answer me?
The
Why?
answer is sea cucumbers, which might be the most
What
surprising based
the
on this.
hell?
So let me explain how scientists figured this out. They used a 3D reconstruction process called high-resolution physical optical tomography. A name you have absolutely no correction process
hold
called
on.
high-resolution physical optical tomography.
So, HRPOT. Hardpot.
A name you have absolutely no reason to remember. What they do for this 3D process is grind down the fossil layer by layer
Oh my
and
God.
take a picture at each layer, like fucking claymation, you know, like moving it a little bit, taking a picture. So you're left with hundreds of photographs that can be kind of stacked on top of each other
Right,
to
right,
create a 3D shape. It's like
That makes
3D
sense.
printing, but completely opposite. This
Yeah,
3D
like
model
the
of Silurian
inverse.
Cthulhu helps scientists look at their water vascular system, a body system that echinoderms use for fucking everything. Locomotion, food and waste transportation, respiration, and all in one system.
tube.
Like the men's 10-in-1 shampoo that you
Ah,
can use for
wow.
like toothpaste and also motor oil. Solacina's
yeah.
particular water vascular system had sea cucumber-like traits. So that is the understanding for now. Other than that, what else can you say about a creature that looks like this? Just classic case of a little guy that hangs out. Another strange specimen from the Silurian was
He looks like a
Nyctozoon, an
train.
animal that, like
I
Hallucinogeneus
know.
and the Cambrian, was so bizarre scientists initially had it flipped upside down. It was first discovered in Scotland in the late 1800s, but wasn't described, i.e. given a scientific name, until almost 50 years later. Nobody
Wow.
wanted to touch this thing. Couldn't even give it a best guess. The first jab at classifying it, and the scientist
That's
who named it,
a
was
best.
DJ Scorefield in 1937. He understood it as some sort of proto-chordate. You remember chordates, like us and all other vertebrates and tunicates, are a little phylum. Proto-chordates are earlier offshoots that kind of split off before chordates became true chordates. So
Right.
chordates and proto-chordates have the same characteristics generally, but they go about them in practice differently. They develop differently. Honestly, it doesn't even matter for this conversation because Scorefield was wrong. We know that now. But this wasn't known for a long time. So for the next 60 years, Nyctozoon was studied even more
Look at him!
based
Kinda
on the
cool.
assumption that they were protochordate. This was unbelievably confusing. Like trying to figure them out with a starting point of wrong. You know when you have those really long
Yeah.
math equations where none of your steps are making sense and you're doing extra steps that aren't even remotely close to what you learned in the lesson plan? Then
Yep.
No.
Oh, wow. Oh, yeah. So the way math is taught, right? They start you out with the basic theory, and then they just toss you into the deep end to see if anybody can logic their way out of it.
Right.
And then they hope through you floundering, you realize how small and insignificant you are. And they crush your ego, and then they bring you back into the fold.
And this is why
Mhm.
I was an English major.
Yeah.
go back and you realized the first answer you got in the first step was wrong. That was the study of this creature. Then
Great.
finally, in the 90s,
We
new,
related to
more
that.
well-preserved fossils were found and helped scientists realize that they had their shit all mixed up. The previous fossils were all smushed up and laterally flattened. The reconstructions were all turned around and shit. These new fossils were now three-dimensionally preserved. Soft tissues were preserved, and their traits,
Oh,
now
wow.
in clear view, lines them up very neatly with arthropods, specifically thylakocephalans, an extinct group of crustaceans alive from the Silurian, maybe Ordovician, to the Cretaceous. Finally,
Wow.
it was making sense. Nyctozoon and its relatives had bulbous compound eyes and
Big-ass
raptorial
eyes.
limbs. Absolutely precious little guys. All right, I
Yeah.
now want to introduce you to my favorite Silurian strange
Here we
specimen,
go.
Okay.
Aquilonifer spinosus. That doesn't sound right.
Aquilonifer.
Aquilonifer spinosus.
Aquilonifer.
What is going on here? It was found more recently in 2016 in the UK.
It's got
and
little
this is the
things.
reconstruction we're now working
Clappers.
with. Definitely some sort of arthropod, right? With appendages coming off of each segment,
Bells.
kind of like centipede or millipede-like in form. Real thick antenna that kind of look like they each have individual sentience. And then weird bolts
has tail
attached
feathers.
to long threads attached to their back. Are
Huh.
those parasites? Is this some sort of unusual
Like a
plant-animal
peacock.
combo? A symbiosis of some sort? No. Those little tether balls have been determined to be babies. And the main guy those bolts
What?
are attached to is the mama, or
What?
papa. This is an individual with its 10 juvenile offspring attached to it by long strings. A
What?
parenting style unlike any we're familiar with in the natural world, but that we can definitely draw parallels to in the classic American mall. Parents
Okay.
with kids on
Yeah.
leash backpacks. Kids cannot fly,
Oh.
not stray too far from their parents, find themselves in any danger. Parents can go about their business without the weight of a child on their back. Of course, there's always a chance that I or any other passerby will trip over the kid, but that's not my problem. That's on them.
Damn.
Aquilonifer spinosus
Damn.
was named after their resemblance to kites. Their name means kite bearer. I like it a lot, to be honest. I
Kite
feel like I
bearer.
can imagine what it would be like to crawl along the ocean floor with creatures attached to you by string. I'm imagining it right now, and it feels really natural. I feel like I've done it before. I think I was maybe this in my past life, and I honestly don't mind it. All right.
Damn.
We're moving on to the next section of the video. I'd mentioned...
What good deeds did you do as an Aquila Nifer Spinosus to end up as cool as you are today?
Wait, that means my past life I might have been a crab.
Oh my
Giant
God.
crab. Or maybe a big squid.
You were a squid.
in the introduction that a major event that happened in this period was the invertebrate migration to seemingly inhospitable habitats. The habitat in question was land. While we humans enjoy a crisp autumn morning or a summer breeze in July, the transition to land might as well have been hell on earth. And a journey our own ancestors, the vertebrates, wouldn't be ready for another like 50 million years. Some arthropods, though, just felt like they saw what they needed to see in water,
let's go.
and they're done that, and were ready for a new challenge. One that had dry, suffocating air, gravity on full blast, desiccation around every corner. But it was a habitat of opportunity as well. Plants to feast on with no competition. No predators lurking in the shadows. Very promising. These arthropod pioneers had a long road ahead of them. Lineages had to go through small changes that built up over millions and millions of years to allow them to live on land full time. Their exoskeletons evolved to be waxy and waterproof to prevent desiccation and evaporation. New respiratory structures emerged, etc. One of the first full-time residents, at least that we know of, is called Pneumodesmus pneumoni, a millipede-like myriapod. So millipede relative, but not millipede. I talked about them in one of my first YouTube videos.
I was about to say you did,
Millipedes. So I'm just going to give them a quick little rundown. If you want to learn more about them, go to the video. Pneumodesmus pneumoni was a pretty typical millipede, even though it wasn't. But this fossil had openings all over its exoskeleton called spiracles, which proved to be a very crucial find for the invertebrate transition to land. Spiracles are tiny networks of tubes that allow air to diffuse into the bodies of arthropods, specifically myriapods and insects, a working terrestrial respiratory system. These networks would end up playing a huge role in the evolution of arthropods, especially, most notably, in the Carboniferous period, which we'll get to in a couple episodes. While Pneumodesmus pneumoni is the earliest terrestrial arthropod we can put a name to, there's trace fossils that have been found even earlier than that, possibly even going back into the Ordovician, which I mentioned in the last video. These are tiny little footprints, some of which have been found in the largest organisms on land at the time, the giant fungus called Prototaxites. It could get to 26 feet tall and 3 feet wide. And no, I will not be hearing anybody out. Prototaxites was first discovered.
I was like, what do you mean?
Hear me out, man. Like, what could you possibly have to say about this giant fungus? Explain yourself right now.
Oh my God.
Mid-1800s, and was later described as some sort of giant rotten conifer trunk. We now, of course, understand that trees didn't exist yet, that we know of, but this was the 1800s. They had very few puzzle pieces to work with. Later attempts to classify them included giant marine algae, lichens, or even rolled up mats of liverworts. It was a pretty gnarly debate for like 160 years, until just the last couple decades where now a general consensus has been reached for giant fungus. Scientists have been able to detect specific carbon isotopes in fossils that point to fungus rather than plant. So, giant fungus. Exactly what this fungus looked like is more of the debate now. At one point, I think scientists were playing around with the idea that they could have looked like giant mushrooms, cute little head, which would have been sick. But I think gravity and the lack of fossil evidence removes that possibility, unfortunately. The most common reconstruction is this skyscraper look, which is definitely what they would have looked like to the only animals on land at the time, the little millipedes. The orientation is based on their similarity to tree trunks, but new evidence suggests that they were just as likely to grow horizontally as they were vertically. And of course, the networks they had underground must have been fucking nuts for how big they got. So they were probably growing, who knows, fuck which way all over the place. The Silurian was a big time for plants too, evolving systems that would eventually allow them to grow so big we could drive a fucking car through them. So I think the best person to explain this monumental time for plants is the plant expert, Joey, from Crime Pays But Botany Doesn't. He must know, like, every single plant, dude, and he's a total badass. Luckily, I was able to track him down while he was on the road to put a little clip together for this video. If you don't know him already, you're gonna fucking love him. So, here he is talking about prehistoric plants.
So today we're going to talk about the Silurian period and the plant life that existed on Earth's surface at that time. And there wasn't a lot. At least there's not a lot that we know of. Only a few dozen genera. But first we got to talk about what Earth's atmosphere and landscape were like at this period. Now keep in mind there wasn't much soil yet. Okay, to get soil you need weathered rock and organic material.
Yeah.
And that makes sense, but it's also so weird to think about because dirt is everywhere.
Yeah.
You know what I mean?
But how do you make dirt?
Right.
Yeah, good point.
Like, oh man, ew. Also,
But
this
like
is
soil
gross.
is what we're talking
No,
about.
yes.
Yeah.
I understand. But there's no organic matter.
Right.
But like soil's everywhere.
Yeah.
You know, when you
talk about a farmer and you go, there's sand everywhere. You go, right, useless. Soil though, gold.
Yeah.
Right? Black
Yeah.
gold. But there is a difference, and it's good to actually break down that we had to create systems to create soil to support systems.
Yeah.
Yeah, absolutely.
The weathered rock part is easy. There's plenty of rocks exposed at Earth's surface, of course, at this time. But the organic material part is a little bit trickier, okay?
Right.
It's thought that most of the organic material, if there was any, came from decomposing lichens. Now, of course, the lichen's just a symbiosis between an ascomycete fungus, generally speaking, and an algae. The fungus kind of farms the algae, if you want to think of it like that.
Wow.
But there's no plant life involved. But they can weather and break down rock. And then, of course, when the lichens die, that eventually would build soil. That's an organic material to actually build soil with. But regardless, there probably wasn't a lot of soil, and it wasn't very nutrient-rich or very deep. Certainly, those plants had their work cut out for them. Oxygen levels were certainly a lot lower at this point, too. Today, they're at 21%. In the Silurian period, they were roughly around 14 to 15%.
Oh.
CO2 levels back then were also 10 to 15 times higher. This would have been a very uninviting place for any vertebrate alive today, right? It'd be choking, suffocating, and extremely warm. That said, this is when plants are thought to have really gotten going. The first plants stayed kind of close to the freshwater, little inland estuarine systems that they are thought to have evolved out of. None of these got very tall, okay? These kind of formed dense, probably what looked like a taller shag carpeting of green around the margins of some of these freshwater ponds. Now, the two most famous genera are the genus Cooksonia and the genus Baragwanathia, both of which...
I'm so sorry.
Those are such good names.
I'm so
We're
sorry.
going to pause you right there, son, and we're going to run that back.
Cooksonia, as in someone cooked here. Okay.
Yeah, okay. That's a good one.
I don't have anything for that.
Baragwanathia. Baragwanathia. My new president. Baragwanathia.
Baragwanathia. Okay.
Both of which had vascular systems, which is pretty impressive. They had internal plumbing. So these were vascular land plants, Cooksonia and Baragwanathia. Cooksonia looked kind of like a whisk fern today, just a leafless green photosynthetic stem with little cups bearing sporangia at the distal ends. It probably topped out at 6 to 8 inches, in some cases maybe 12 inches tall. And Baragwanathia looked like a big green pipe cleaner, kind of more akin to today's lycopods, like Lycopodium, Lycopodiella, etc. But either way, these were not astoundingly complex photosynthetic life forms.
Right.
I mean, for the time they were, but compared to what we think of today, these were not that complex. Caia was another genus. Caia was a non-vascular plant from this time period. Zosterophyllum is another one that actually had, I think, Zosterophyllum had a vascular system, but either way, it was just one of these green pipe cleaner looking things. But think of all the plants that we'll never know existed because they never got fossilized, or the rocks that they were fossilized in later got destroyed. I mean, it can be kind of a trick to find rocks that are from that actual age of Earth history. Totally different time period. I mean, it would look so foreign to anything that we know of today. And that's kind of what has me so fascinated with it. I mean, just to imagine what those ecosystems look like, and also to imagine what was evolving and what the selective pressures and the environmental stresses that these things had to deal with back then. I mean, especially CO2 levels and
I was going to say the CO2 levels were nuts.
Yeah, they were fucking out of control.
That would be a weird thing.
Big
Moving
greenhouse.
from water to land and having to deal with the threat of drying out, the threat of desiccation, that's a whole other palette of environmental stresses and selective pressures that can direct your evolution. So either way, totally different time period to think about. Might as well be another goddamn universe, but fascinating nonetheless. And again, we've only got a small glimpse of what was actually going on back then. It's like trying to put together a 1,000-piece puzzle when you've only got 9 or 10 of the pieces. So anyway, that's all I got for you today. Have a good rest of your day. Go fuck yourself. Bye.
A phenomenal
Thank you.
science.
Appreciate it. So I was super locked in throughout that whole speech, and then right near the end, I had like an out-of-body experience about the camera angle, and I'm just like, it's like we're sitting on his lap, and he's just like spewing out plant information. So rewatch it, but from the viewpoint of sitting on this man's lap while he talks to you, highly comfortable, uncomfortable, depends on what your vibe is. I don't know, I'm not judging, just saying.
Oh my God. I got like distracted because he was like, oh, it's just a small piece. There's only so many things that we know because everything didn't get fossilized. And I just like went on this like mental journey about like how distressing it must be to be in this field of work and just realize that there's so much that we know but don't know enough about, and then there's so much that we don't know. And if you could just find a thing, then you would know more. But would you really know like any more than we already know?
It would help you very little, but also a ton. It would be groundbreaking. Yeah.
Sums up how the Silurian period ended. Periods that end with some sort of extinction have a pretty clear-cut boundary on where one period ends and one begins. Kind of visualize it in the rock. The most extreme case being the KT boundary, with the asteroid going all over the place. The iridium in the asteroid that wiped out the dinosaurs can be seen all over the world. The Silurian didn't have this. Kind of just ended. Kind of a go fuck yourself to scientists, because they had to get a boundary internationally recognized by a committee of specialists, which didn't happen until 1977. They marked the end of the Silurian and the beginning of the Devonian by the first appearance of a graptolite species called Monograptus uniformis. Graptolites are colonial animals, and this particular graptolite species first appeared about 419 million years ago in association with some trilobite and conodont species. Whatever. It's just complicated, and that's the point. But there were some minor extinctions that happened throughout the Silurian, specifically 3, that played over a time span of like 10,000 to 200,000 years. The first one was a global cooling event that also had a huge drop in deep ocean oxygen about 434 million years ago, leading to the extinction of many deep ocean and open ocean species like conodonts, trilobites, and graptolites. 6 million years later, there was another minor extinction, another oxygen drop that led to the extinction of 95% of graptolite species. Tough shit for them. And the last one, 4 million years later, seems to have been due to a global sea level drop due to glacier formations that wiped out a shit ton of graptolites and some additional conodonts. These extinctions likely played more of a local role than a global one, but were extinctions nonetheless. By the end of the Silurian, the Earth was ramping up to introduce the largest predators the Earth had ever seen that we know of. So stay tuned for that in the Devonian period.
We are ready. Skitten, is there anything else you'd like to wrap up in this video? You have a couple notes here.
All of my notes are just about they're just so disorganized. Anyway, all of my notes are just about stuff that she talked about and like animals that I found interesting. And I just love how in every set of notes, trilobites makes it.
Yeah. Oh, that's a good thing.
Like I haven't learned enough about trilobite. Every time she'll just mention them casually, and I'm just like,
so maybe you won't get any conclusive, like, big highlights every time we do them. Yeah. But if you keep track, we can get like a theme going forward based on the notes. Make sure you end date your notes here. Make sure we know what date that we ended. And then we can go back and review some of these things. I really like going over some of the plant life. You know, we've really kind of not talked about that. I know land existed, but we've been stuck in the water. You know, and I'm really fascinated about that, but I'm like, bro, what's going on above land? What's happening with all these plants up here?
And I feel like she hasn't addressed it just because there wasn't a lot going on. And I really appreciate like her bringing in other people to talk about. Like, she's like, that's not my area of expertise, but you know whose it is.
Yeah, that was freaking cool. And of course, you know, we got another pit stop to make to learn more things. This is gonna keep going for the rest of our lives. I hope you're ready for it. Skitten, thanks for bringing me on. Can you give me a rundown of a couple interesting things? We know we had the Cthulhu thing. What was that one called? That's probably my number one.
Where was it? Cthulhu. Where is it?
It's definitely a second page note.
Where is it? I wrote it. Solacina Cthulhu. It wasn't found until 2019.
Yeah. And it has 47 feet.
45 tentacled feet.
Yep.
And it was a sea cucumber's cousin, basically.
It has like one big piping system. Did you write down what that was called?
Nope.
But it did everything. It breathed, it shit, it walked. One system. Very cool, very efficient.
Yeah. And then what is this one? Pterygotus, the Dark Souls crab.
Dark Souls crab.
Yeah, it was a type of sea scorpion.
6 foot fucking scorpion crab of the sea.
It was massive.
Awesome shit, dude. All right, thanks you guys for joining us. Let's hear about some of your guys' favorite things you learned in this video.
I had a great time. I hope you guys had a great time. Don't forget to leave your reaction requests and recommendations down in the comments below. I almost said down in the puzzles below. Like, I don't know. And other than that, peace out, hope it skits. It's skittin' lit.
We're skittin' smarter.